Okay, now the second question is that you have to find the interval of convergence, that means radius of convergence for this given series. And here they have specifically mentioned that do not attempt to check the convergence at the endpoint. So now our question has been minimized. So we are not checking the endpoints. We have just finding the radius of convergence, that means the interval. So let's start with the question. So the given series is summation of n equals to 1 to infinity 2 raised to n x raised to n upon n 5 raised to n. So here we are going to use the ratio test. So now let's first find out the un. So our un is nothing but the given series, that is 2 raised to n x raised to n upon n into 5 raised to n, and our vn. So now as we are finding out the using the ratio test, so you have to calculate the un plus 1, that is 2 raised to n plus 1 x raised to n plus 1 upon n plus 1 into 5 into n plus 1. So now by using the ratio test, you have to find the limit of n tends to infinity un upon un plus 1, and we are taking it in the modulus. You have to remember this thing. Then so the limit of n tends to infinity, what is your un? 2 raised to n x raised to n upon n into 5 raised to n into, taking reciprocal of your denominator, n plus 1, 5 into n plus 1 divide by 2 raised to n plus 1 into x raised to n plus 1. Okay, so now what you have is limit of n tends to infinity. So here you can say as keep un as it is. Then you have n plus 1 as it is, or you can just take out n common. If you take n common, inside it would be 1 upon n, then 5 raised to n into 5 upon 2 raised to n into 2 x raised to n into x. So here you can cancel out terms, 5 raised to n and 5 raised to n cancel, n and n cancel. So now you can see x is here constant, which we are trying to find out. So L equals to limit of n tends to infinity under modulus of what we have, 1 plus 1 upon n divide by, okay, into 5 divide by what, in the denominator you have 2x. Here x is constant, so take it outside, 1 upon mod of x, and if you apply the limit here, it would turn as 1 upon infinity 0. So but if you check this term would become 0, then you get 5 by 2 as limit. So now here you are using the ratio test, right? So by using ratio test, you say that the given series is convergent. That means the limit, if it is greater than 1, then we say it is convergent. So we are finding the radius of convergent, right? So we are considering the given series is already convergent. So our term, that is 5 by 2 and 1 upon x modulus, is greater than 1. So just take the reciprocal. It would be 2 modulus of x upon 5 is less than 1. So now it would be mod of x less than uh, 5 by 2, right? Then remove the modulus, it would lie between minus 5 by 2 and 5 by 2. Hence the interval we get is that x belongs to the interval minus 5 by 2 to 5 by 2. Here if you see the question, it is specifically mentioned that you don't have to check the, here it is specifically mentioned that you don't have to check the endpoints. But if they have not mentioned that you don't have to check the endpoints, what you have to do is that these are the points you have got. So put this minus 5 by 2 in the main equation and find if it convergence or not. If it is convergent, then it satisfies the endpoint. Then you can give a square bracket or check both the points at such and then write the radius of convergence. So in this way, we have solved this question.